dear students.
Okay, so this chapter is very important. This is for transport layer protocol. For transport layer protocol, we have this congestion control and quality of service. These two things are there. So how we can control the congestion? Okay, so here at first, congestion means what? We have traffic inside the channel. We have a traffic inside the channel, and we need to control those traffics. Okay, so how we can do that? Okay, so here the main focus of congestion control and quality of service is data traffic. In congestion control, we try to avoid traffic congestions. That means we have a traffic there, and we need to control those traffic. Okay, so in network layer, we know that we have a flow control. So we need to take some there are some rules to control those traffics. So here we have these traffic descriptors. Suppose we have this is a data rate, and this is the maximum burst size. Means maximum we can send this amount of traffic. That is the maximum burst size, peak data rate. Okay, and this is the average data rate. Okay, so traffic, we can just graphically represent those traffics in this way. Okay, so this is the maximum burst size, and there is average data rate is this, and maximum you can send this amount of data. So the data can be, we can send the data in this way. This is a constant bit rate. That means data can send in the constant way, and this is variable bit rate. The data can be sometime data can be huge, or sometime data can be low. So different type of variable bit rate can be there. And here you can see in this third picture, we have a bursty data as well as this is the small. That means the low data traffics are there. Okay, so now the congestion. What is congestion? Congestion means congestion is a network may occur if the load in the network, the number of packets sent to the network. So that means is greater than the capacity of the network. So when the network capacity is lower than the packets inside the network, then the congestion can happen. So if the channel is congested, then what will happen? If the channel is congested, then data cannot be moved through the channel. Okay, so there is a permanent blocking can be there, so no one can move. So we need to control that thing. Okay, so the number of packets a network can handle, that is fixed. So according to that, we have to control the traffic. So congestion control refers to the mechanism and techniques to control the congestion and keep the load below the capacity. Okay, so our capacity can be low. According to the capacity, we need to low our data movement. So this is the router, and this is the queues. The data can be passed here. So these are the different interfaces, and the input buffer, input data can be wait inside the input buffer, and output buffer, this is the output buffer. So when you are passing some data, so the output buffer, inside the output buffer data can be stored, and according to, so if the output buffer is full, then you have to wait. There must not be any data, you must not send any data to that output device. Okay, so here you have to see two mechanism. Just a minute. Okay. So congestion control refers to techniques and mechanism that can either prevent congestion before it happens or remove congestions after it has happened. So two types of things can be there. You can just control the congestion before you just control the congestions, or you can remove the congestion. Okay, if there is congestion is happening, then you can remove it, or before occurring any congestion, you just prevent it. Okay, so here we have open loop congestion control and closed loop congestion control. So for open loop congestion control, we have retransmission policy, window policy, acknowledgement policy, discarding policy, and admission policy. So these different types of things are here. Okay, and for closed loop we have back pressure, choke packet, implicit signaling and explicit signaling. So these type of things are here. So closed loop and open loop. So this is the back pressure method for alleviating congestions. How we can do that? See, in a back pressure, this is a technology what we can use for congestion control. See, this is our source and this is our destination. Okay, so here we have what we can do, that the pressure, that means, see, this is the destination. So when we are sending the data from source, there is different milestone we are just providing here, that is 1, 2, 3. These things are there. So in node 3 we are seeing that there is more data. Okay, so data is heavily congested here we have more data here. So we can reduce the things, we can control these congestions to reduce the data in the backward. Okay, we are sending the data in the source again. Okay, we just retransmit the data again into the source machine. Okay, so this is that means the backward transformation is going on. So because node 2 and node 3 there is this is fine, the data is slow down here, but node 3 is highly congested with the data. So we can retransmit, we can move our data to the backward. Okay, so that is back pressure. Okay, so there are different techniques, that is, this is the one thing how we can do congestion control. Then choke packet, this is there we have a packet. Okay, see, this is a choke packet, this one is a packet, here is a packet. So choke packet, this is a packet which is sent by a node to the source to inform it for congestion. Okay, that yes, there is a congestion. So this packet have the information that this congestion, this third node has the congestions, and this is retransmit here. The information is sending to the source. Okay, so data can move here, or here in choke packet, here we can send the data directly from this to this. Okay, the message is sent directly to the congested node to the particular source node. Okay. Now we have two different examples, that is congestion control in TCP and congestion control in frame relay. So this is a figure, that is, here you can see that a sender and receiver is there and we are passing the segment. Okay, so here you can see that the segment 1 is sending, first segment, this is the round 1, the first segment 1 is sending to the receiver and acknowledgement is getting, and here also these things is going on. So in the segment 3 then acknowledgement 3 is passing to from the receiver to the sender, and then segment 3, in this way this is going on. So here you can see that we have total, suppose at first we have 2 to the power 0, that is the first frame, and it is sending here, and again we have the next frame, that is 2 to the power 1, then the 2 segment 2 is passing there, and in this way it is going on. Then 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 2. So 3, this is missing actually, because here we are counting the round of transmission is 2 to the power 0, 2 to the power 1, 2 to the power 2, in this way. So 2 to the power 4 is here, and we are sending these values, the segment 4, this segment 4 is passing here, and acknowledgement 5 is going in this way, because it is 5 and 6, 7, we can't have these things because we don't have 2 to the power 3 means 8. So this number of things we need to skip. Okay, see here, this 1, 2, 4 and 8, these values we can send. Okay, so here we have to start from 1, and after round 1 we have 2, and then after round 2 we have 2 to the power 2, that is 4, and then after round 3 we have 2 to the power 3, that is 8. So this is the slow start algorithm. Okay, so here the size of the congestion window increases exponentially. You can see we can getting the data, and until it reaches to the threshold. So the value we can have, that is the power of 2. Okay, and this is the window. What you can see, this is our congestion window, what the data is actually storing here. Okay, then this window, suppose 2 to the power, in case of these 3 windows, it cannot store this one, but it can store the 4 windows at a time, because we have 2 to the power 2. So congestion window, the figure of congestion window should be this, like this. So this is a slow start process. So in this slow start algorithm, the congestion control window increases. This is the exponentially. It can increase. You can see the data, the window size is increasing exponentially. Okay. So here we can avoid the congestion avoidance and additive increase. So how we can avoid the congestion? Here you can just in the congestion window, we are not getting the exponential value. We are passing only the value, that is the 1, then 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, in this way. Okay, so in this algorithm, the sound that is the size of window size should be increased additively. Okay, additive increase. Here we can see that this is a additive increase. Additionally, we can just add 1 by 1. Okay, so if we are doing in this way, we can avoid the congestion. But here you can see we are doing this thing exponentially, but here we can add the value 1 by 1. Okay, so this is our congestion window. So the congestion avoidance algorithm, the size of the congestion window increases additively until congestion is detected. So these are the points you have to remember, that sometimes for congestion avoidance we need to follow the congestion window increase additively. Okay. So an implementation reacts to congestions detection in one of the following ways. If detection is by timeout, a new slow start phase starts. Okay, so if there is timeout, if after sending the informations, if you don't get the acknowledgement, the receiver, the sender, if the sender did not get any acknowledgement, then it needs to detect that it is timeout, and slowly it can start the phase again. Okay, it can retransmit the data again. If detection is by 3 acknowledgements, a new congestion avoidance phase starts. Okay, so if we have this, if we get the all the acknowledgements, then the acknowledgements is getting, so we can avoid the new phases of avoidance phase we can start. Okay, so if there is no acknowledgement, then you have to retransmit the data, and you have to start the timer, and again you have to go start with the slow phase process. And if the detections is by 3 acknowledgements, then a new conditions avoidance phase will be start. So this is the TCP congestion policy summary. Okay, so here you can see that we have a slow start. This is a slow starts is here, and we have different. This is the timeout. This is the congestion period, and if see we have a slow start and congestion avoidance. 2 things are there. So congestions, if there is, you need to avoid the congestions, then what phase you have to follow? So this is the window size, that is 1 MSS. So this is the congestion window, and here you have to, and this is the threshold value, that is half of window. And here you can see this, if this is the if conditions is happening here, then what we can do. So this is the conditions. Here also see, you can come back to here if there is conditions is occurring here. Okay, then that means you have only 2 things, that is if detections is by timeout, then you have to start the slow start phase again, and if it is if detection is by 3 acknowledgements, different acknowledgements if you have, then you can just new conditions avoidance phase you can start. Okay, that means if acknowledgements is done, then you have to start the new phase. If there is timeout, then you have to start the slow phase process. Okay, so this is the thing. This is from slow start you can go to the conditions avoidance. From conditions avoidance phase to again you can go to the slow start phase, or from slow start phase you can come here to this congestions avoidance phase. So what is mainly important, that is quality of, okay, so quality of service, that is also very important thing. So these are the different congestions control mechanisms, how you can just control it. So there are two things you have to remember, that is you can avoid the congestions and you can detect the congestions. For avoidance, you have to increase the window size additively, okay, and in case of slow start algorithm, the size of the congestions window is what, that is exponentially you can increase the value of congestions window, okay. So these are two things. And for detections, if you want to detect the congestions, then what you have to follow two things, that is here you have to, if there is timeout, then you need to start the slow start phase, and if there is detections of the three acknowledgements, different acknowledgements if you have, then you can start the new congestions avoidance phase, okay. So after that we have quality of service. Quality of service means what? Quality of service is an internetworking issue that has been discussed more than defined. We can informally define quality of service as something flow seeks to attain. That means how we can improve the service, the quality of our service, how reliably or how securely data can be passed from one source to another destination, okay. So here these different flow characteristics we have reliability, we have delay, jitter and bandwidth. These are the flow characteristics when the data is flowing through the network. So we have these characteristics. So reliability is what? Okay, so reliability means what? Reliability means when you are sending the data, then there must be some acknowledgement from the receiver end that yes, the data is received by the receiver. So if this type of things is there, then that communication channel is reliable. That means the sender will be sure that yes, we have the sender will be much more sure about that the data is received by the receiver properly, okay. So this is the one thing. So this is the reliability. And another thing is delay. The delay is what? That means what is the timing, the total time sender is a packet is actually taking to reach to the particular receiver end, okay. So that is the delay, okay. And another thing is jitter. Jitter is what? So it is this jitter is actually the variation in delay for packets belonging for the same flow. That means what is, suppose the data is actually you are passing, and suppose you have different data like 0 packets like 0, 1, 2, 3, and it can arrive some delay. Suppose first packet is reached to other destinations as 20 milliseconds and the second packet for 21. In this way it is going on. So these variations, this is called delay. If there is variations of when the packets is moving from source to destinations, if there is a variations of this delay means delay factors, that is called jitter, okay. So and after that we have a bandwidth. Bandwidth means the channel capacity, obviously much this is very important factor. According to the channel capacity we can send the data, okay. So this is the flow characteristics, different flow characteristics. So there are different techniques what can improve quality of service, that is scheduling, traffic shaping, resource reservation and admission control, okay. So scheduling means what? Scheduling means FIFO queue, that is fast in fast out, okay. That means you can see, you can when the data is arrived to the queue, then before arriving to the queue there is a checking that whether the queue is full or not. If it is full, if it is yes, then it can be discarded, and if it is no, then data can be passed to the queue, okay. So it can arrive to the queue, and after processing it can depart, Okay, so this is the FIFO queue mechanism, that means scheduling technique, that is one by one. If one process is passing, one data is passing, then another process have to wait, and before passing the data to the queue, the buffer, the network buffer, then in the queue, then it has to, there must be a checking that whether the queue is full or not. Okay, so this is the thing. Okay, so in this way we can do that. So this is the FIFO queue, and after that we have priority queuing. So we have classifier. Okay, we need a classifier. So classifier will check that the priority of the data. Suppose we have lots of data, and suppose the multiple data are there, so according to the priority we have to send the data. So we have two different types of queue, that is higher priority queue and lower priority queue. Okay, so if the higher priority queue is full, if it is yes, then it can be discarded. Similarly, in case of lower priority queue, if it is full, it also discard. The same policy is there, but thing is that when the two packets are the same, two packets are passing, then the higher priority packet should be passed at the processor at first. Okay, so the switch turns to the other queue when the current one is empty. So this is the switch. Here is the switch. Okay, so at first we have higher priority queue should it should have the chance to send the data to the processor, and if the higher priority queue is empty, then lower priority queue should be there. So higher, at first the value, the priority, higher priority queue value queue should be empty, and then only lower priority queue can be get chance to access the processor. Okay, so this is also the congestion control technique, or the quality of service. You can improve the quality of service in this way also. So another thing, that is traffic shaping. So this is also weighted buffer fair queue. Here also we have different weight, that means weight 1, weight 2, weight 3. These three things are there, and we have different switch. Okay, so the turning switch selects 3 packets from first queue, then 2 packets from the second queue, and 1 packet from the third queue. The cycle repeats in this way. So here this is the classifier, and we have different queue, weight 1, weight 2, weight 3. So the first packet should have the high priority, so weight 1, so it can take 3 packets, it can take 2 packets, so parallelly it can select the packets from the queues. Okay, so in this way it will be going on. Okay, so this is the thing. So here after the processing, the data can be depart. So this is the weighted fair queuing. So now we have another thing, that is leaky bucket policy. So leaky bucket policy means what? This is very important thing. See, so this is a very interesting technology also. So leaky bucket means what? We have a bucket, and see, we have a small pore at the bottom of the bucket. Okay, so if we have a very small pore, so the tap is open and the water is coming, storing inside the bucket, and one by one the drops is coming out from the bucket. Okay, so this is, there is a fixed flow. So this is the fixed flow, and this is the bursty flow. We are passing the data, so this is the bursty flow. Okay, but the data is passing here, this is at a fixed rate. Okay, so that means the whole data are there are lots of data are there, but the data are passing through the network at a fixed rate. So that means it is a means there is a consistency. Okay, so this is the bursty flow, and this is the fixed flow. So this is a leaky bucket technology. So leaky bucket is very important technology for quality of service, and it also done the congestion control also. Okay, we can prevent the congestion in this way. That means one by one the drops is coming out from the bucket, so the network will be smooth, no congestions can be there inside the network. Okay, so this is the thing. So here you can see that for sender, that means the tap, the rate of, this is the bursty data. Okay, sometimes there are huge data and sometimes there is small data, but when the data is passing from this pore, then the data can be passed in a fixed rate. see, this is the fixed rate. So the congestions can be prevented here. In this way we can control the congestion. And another thing, so how we can do that in the leaky bucket implementations, you have to check that this is the arrival, whether this is full. If it is full, then okay, you can discard it. If it is no, then you can store the data inside the queue and remove packets at a constant rate. This is the constant rate. Okay, so you have to provide the leaky bucket algorithm here. So at the constant rate, the data can be passed to the processor. Okay, so this is the leaky bucket implementation. So leaky bucket algorithm shapes burst traffic into a fixed rate traffic by averaging the data rate. It may drop the packets if the bucket is full. Okay, so this is the very important thing, how we can do that. So leaky bucket algorithm shapes the bursty traffic. Remember it can shapes the bursty traffic into a fixed rate traffic. Okay. Now another traffic shaping we have, that is token bucket traffic shaping. It also allows the bursty traffic at a regulated maximum rate. So here you can see we have a token, lots of token we have, and we have to pick up a token. Okay. One token removed and discarded per se. Okay, just a minute. Okay, so you have to pick up one token, and you have to add this token here. That is, you have to remove one token and discard it parcel transmitted. That means here is also a queue and you have to check the queue is full or not, the same thing, and after that you have to put one token at a time. Okay, one token added per tick. Per tick means there is a clock pulse. Okay, for a single clock pulse, the one token should be passed. For the second clock pulse, the second token must be passed. So in this way it will be passed. Okay, so one token removed from here and it can be discarded, parcel transmitted. So so this is also another thing, that is token bucket policy. So token bucket and leaky bucket, these two things are very important for bursty traffic regularization. Okay, it can regulate the bursty traffic, it can shape the traffic. And now we have different integrated services what it can provide. So integrated services means it can provide the signaling, flow specification, admissions, or service classes. So these type of things are there.